Assalamu alaikum dear student. Today from chapter 7 electrochemistry we are going to discuss oxidation state and rules for assigning oxidation state. Oxidation state or oxidation number. It is an apparent charges positive or negative on an atom of an element in a molecule or an ion. These numbers are useful in naming compounds, in writing formulas, and in balancing chemical equation. Oxidation number are the positive or negative charge on an element or on an ions. The color of solution changes with change of oxidation state. There are some colored compounds which show the color changes when the oxidation state is changed. There are some rules for assigning oxidation state. Number 1, it is 0 for all elements in free state. If the elements are in free state like hydrogen molecule, chlorine molecule, sodium and nitrogen molecule, then their oxidation state is 0. Hydrogen molecule, chlorine molecule and nitrogen molecule exist in nature as a gas, so they are considered as an element, and in elemental form their oxidation state is 0. For simple ion, it is same as charge on it. Simple ions, for example, the elements of group 1, group 2, group 3, group 7, when they lose electron or when they gain electron, they acquire positive or negative charges which are known as ion. So for the simple ion, the oxidation number is same as the charge on it. For example, the elements of group 1, 2 and 3 carry +1, +2, +3 oxidation state. For example, sodium and potassium belong to group 1, so their oxidation state is +1. Beryllium and magnesium belongs to group 2, so their oxidation state is +2. Similarly, boron and aluminium belongs to group 3, therefore their oxidation state is +3. The oxidation number of oxygen in its compound is -2. In magnesium oxide, the overall oxidation state of this compound is equal to 0. But in this compound, magnesium and oxygen, magnesium carry +2 charge and oxygen carry -2 charge as an oxidation number. Overall, +2 -2 equal to 0, so magnesium oxide is neutral. Oxygen also carry -1 oxidation state in case of peroxide. H2O2 is hydrogen peroxide. In this case, oxygen carry oxidation state -1 and hydrogen carry oxidation state +1. As we have 2 atoms of hydrogen and 2 atoms of oxygen, so hydrogen oxidation state here +2 and oxygen -2. +2 -2 cancel out each other, so overall hydrogen peroxide is neutral. While with fluorine, oxygen carry oxidation state +2, as in OF2, oxygen carry oxidation state +2. So there are 3 oxidation state of an oxygen. In its compound, it carry -2 oxidation state. In peroxide, it carry -1 oxidation state, while with fluorine, it carry +2 oxidation state. Oxidation number of each element in group 7 in binary compound is -1. The group 7 element is known as halogen because they are halides former. So in binary compound, these elements carry oxidation state -1 in its compound. For example, fluorine, chlorine, bromine, iodine are the elements of group 7 and they carry oxidation state -1. The oxidation number of hydrogen in its compound is +1 and -1. It depends upon the compounds. When hydrogen makes metal hydride, for example, like with sodium or potassium, it carry oxidation state +1, sorry, -1, while when in the case of non-metal hydride, for example with fluorine, it carry oxidation state +1. So hydrogen in its metal hydride carry oxidation state -1, whereas with non-metal hydride it carry oxidation state +1. Now for the neutral molecule. The neutral molecule, the algebraic sum of oxidation number of all the elements is 0. For example, sulfuric acid is neutral molecule. Now the algebraic sum of the oxidation state of all the elements that are present in this molecule is equal to 0. For example, in sulfuric acid, hydrogen oxidation state +1, as there are 2 atoms, so its oxidation state +2, whereas there are 4 atoms of oxygen, oxidation state of 1 atom of oxygen is -2. As there are 4 atoms of oxygen, so oxidation state becomes -8. Now what is the oxidation number of in sulfur? That +2 -8 become equal to 0. We have to calculate the oxidation state for the sulfur, so that sulfuric acid overall algebraic sum become equal to 0. First step, write the sign of sum between the element, or put the sign of sum between the elements with their number of an atom. Now assign their oxidation number. Hydrogen +1, oxygen -2, 2 multiply with 1, 2, S for the sulfur, 4 multiply with 2, it is 8. Now S, we have to find the oxidation state for S. +2 plus minus minus -8, so S +2 -8 equal to 0. +2 -8, it becomes -6. Now we shift -6 from left side of equation to right side of equation, it becomes +6. So the oxidation state of sulfur is +6. Now how the algebraic sum of oxidation number of all the elements equal to 0? Calculated. Hydrogen oxidation state +2, sulfur +6. +2 +6, it is equal to +8, and oxygen -8. Now +8 -8, it is equal to 0. So overall the algebraic sum or the oxidation number of all the elements that are present in sulfuric acid is 0. In ions, the algebraic sum is equal to charge on ion. For example, permanganate ion, the algebraic sum of the ion is equal to -1. We can calculate it for permanganate ion, manganese and oxygen. Oxidation state of oxygen is -2, as there are 4 atoms of oxygen, so 4 multiply with 2, it is -8. X is used for manganese because we have to find out the oxidation state for the manganese, so that our algebraic sum become equal to the charge, that is -1. +8 -8, when shift from left side to the right side of equation, it is +8. Now +8 -1, it become equals to +7. So the oxidation state for the manganese in permanganate ion equal to +7. As according to the rule, in ion the algebraic sum is equal to the charge on ion, as permanganate charge is -1. So the oxidation state of manganese is +7. Oxidation state of oxygen in permanganate is -8. +7 -8, it is equal to -1. So our algebraic sum become equal to -1. So for the neutral molecule, the algebraic sum become equal to 0, whereas for an ion, the algebraic sum is equal to the charge on ion. The same element may show different oxidation numbers. For example, in carbon monoxide, carbon show oxidation state +2 and oxygen -2. Whereas in carbon dioxide, both the elements are same, but their oxidation state are different. Carbon carry +4 oxidation state and oxygen carry -4 oxidation state. So today we discussed the oxidation number and the rules for assigning oxidation state. Thank you. Allah.